So, hello. This is the first stream, so I probably nothing is watching it from the beginning, but yeah, that is supposed to be English practice. So I'm going to talk a lot. First off, uh, the most important thing in programming, which is music. So let's find some music here. Yeah. You won't hear it, so please feel free to play your own music. But yeah, so as you see, I have an empty folder English speaking virtual machine, and I'm going to write one from scratch. I have opened already the CLion, so let's create a let's shorten. Okay. 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 I wanted to shorten the name, but whatever. Okay, what do we have here? First off, let's create a git ignore. Oh, okay. Computer slows a lot because of the OBS. We'll see how it goes. First off, or no, let's close the CLion for now and create a new folder, like repo, and move all but the repo to the repo. So yeah, and let's start CLion once again. This is slow. Don't need that anymore. Anyway, for the first thing that we are going to do, that I'm going to do, is to create a repository, Git repository, and then I'll probably create a git ignore file, ignore the JetBrains stuff. What's going on? Nothing happens. Oh, okay. Fuck, this line is here. Anyway. No way, it's great. Okay. Exit. Yes. Again. Let's just remove it and create a new project with C++17 and not untitled, but in the English virtual machine in the repo. Okay, that should work. I barely hear the music, so I turn it off anyway. And thanks to that, I'm going to hear myself better, so I will spot every mistake that I speak. So like I said, let's create a repository here. Init. Cool. Now any file. Git ignore, and let's Let's get the JetBrains. Hit ignore. Place. I'll add everything on my own. Okay. Now, kind of okay, but I don't like to have the idea folder in the repo, so yeah, that's better. Okay. Initial commit, and let's go directly to another branch. Git dev, let's say git. Cool. Now, I think. Okay, first off, we are going to create a virtual machine. And the first thing that I need to figure out is to what architecture what architecture the virtual machine is going to represent, because to be honest, I don't want to implement all opcodes, the clone of VirtualBox or so. I will like invent my own architecture and then write a virtual machine for this. So first thing, let's create a doc folder, of course for documentation, and then let's create a file, markdown file, which will be about architecture. Here we will describe whole architecture that this virtual machine represents. Okay. Oh, cool. It's live view of the markdown here. Thanks, Sea Lion. Now, I haven't invented any architecture yet in my whole life, so I will just improvise. So the first thing will be, let's say, registers. Okay, registers. There are okay, for now, for 65 general purpose registers named okay, there will be two kinds of registers for now. R1 to R0, let's say R0, we are programmers, and to true R63 and R ret. Cool. R1 to R63 will be yeah, wherever, and the 65th is a ret, and let's say that we will have one register that is supposed to hold the return values of function return values. So let's make a standard here. Okay. Okay. Okay, I think I will comment that. Introduced. Architecture documentation. Cool. Now, what do we need next? Okay, first off, how the virtual machine is supposed to work. Let's say that we have some disk, and on this disk there is, let's say, operating system for that architecture. And now what should be done to make this work, to run this operating system? So I thought about this for a while, and I think this will be a very dumb virtual machine, so it will just take the raw disk, and it will start to run the code. It assumes that the whole disk is code, let's say, so it is going to start to run the code starting from the very first byte, and yeah, that should work. So it's like it will be the first sector of the disk. I'm not sure whether there will be a sectors, but let's assume that the first sector of the disk is like bootloader or something, so anyone can write any bootloader that he wants, just like in regular computers. Yeah, okay. Now let's create another documentation for opcodes, because we need to have opcodes here. New file. I'll probably merge those files into one file, those documentations into one file, but yeah, it can be done later. Opcodes. For now, I will just list them. So first, let's say move. We'll go with the Intel syntax, because it's more convenient for me than the other ones. So move register anything to let's say another register, array to RB, from RB. Okay, can we do? Okay, that's it. Cool. Next one, let's move from memory to register. Memory pointer moves value from memory. Okay, let's make this one word, or even better, to array. Cool. And now the opposite. Memory cell, and here goes the first very I'm missing this one here and here. Memory cell now to array. So moves value from array to memory cell. To memory cell. Cool. So, as you know, as you probably know, the X I will base mostly on x86 architecture because why not? I kind of know it, but I probably don't. But yeah, we'll see. And in the X x86 we don't have an instruction to move one value from directly from memory cell to another memory cell, so I won't implement this now in this virtual machine. But yeah, maybe some other day. Okay. What's that? No. Sorry. Ilan. Okay, so opcodes. Move. Cool, let's now implement add. And yeah, let's just go with the same as move, but add value from RB to array. Yep. Cool. Now jump. First jump instruction pointer. No. Memory cell. Because the instruction pointer is basically memory cell of the opcode that we want to jump to. So yeah. Okay, let's add another register here. RIP, so it holds so the virtual machine will execute the code that is the next opcode that RIP is pointing to. Let's assume that. So moves instruction pointer moves yes to RIP. Okay, jump. Yeah, let's just forget about flags for now and have, okay, so I will move compared to here. Compare, let's copy this one. Yep. Register to register, register to memory, and memory to register. Compares, and flags. So I will think about flags later because I don't want to bother about that now. But basically, flags are there will probably be similar flags to x86. So yeah, just leave it now. The flags, let's think of flags like result of compare operations for now. Yeah. So jump equal jumps to instruction pointer when, let's say, flag equal flag is set. Well, let's add a dot here. There is not much C++ yet, but we'll get there. Jump equal, jump less. Okay, jump less. Jumps to only when less flag is set. Jump greater. Jump greater. Jumps. Greater flag is set. Cool. Jump. Okay. Jump equal. Jump less. Jump greater. Yeah, it will work for us. Going to work. Let's say for now. Let's add those flags to the architecture. Flags. Flags are set by compare operation. Okay. And let's make a simple list. Equal flag. Set only flags compare. We're equal. Less. Less than second one and greater. Descend only was greater than the second one. Cool. Flags are set. So yeah, let's just flag equal, flag less, flag greater. Okay. Okay, flags, cool. Okay, so let's check whether we need to do anything more. Opcodes, opcodes. Do you have move, add, compare? Oh yeah, of course. Sub and copy pasty. Stop. I can spell it. There's no such thing as subtract, subtract, subtract. Okay. Okay. Everyday learning. Yeah. Subtract. Full odd. Add. Yeah. Yeah. We have odd. Sub. Okay. Int. Int is going to have only one argument. Increments value in array. Okay. Array value increments inc, and that's of course increments. Cool. Let's have mul. It's kind of boring now, but I need to do that now because yeah. Mul. So yeah. Mul is tricky because when you multiply, let's say 32 bits values, you can end up with 64-bit value. In short, you can have overflow, which I think I'm wondering whether I need to take care of it now. I probably should, because or not. Okay, let's now don't bother about this. Okay. Multiplies value from a value of RB. Okay, no. Okay, and yeah, multiplies value of RA by value from memory cell, and multiplies value of memory cell by value of RA. Cool, diff. And here we can't do, because with diff you can end up with a reminder and the result. So I think I will create a new register to handle the reminder. But yeah, divides value Okay, let's do it proper. And the value of, I don't know if I can say divides arrays value by value. Yeah, let's leave it. In ARM register, why not? We can have plenty of registers. And the last one, copy paste. Divides arrays value by value from memory cell. First reminder in, okay, let's call of memory cell and values from RB array. Cool, let's leave it now, for now, because before I'll actually write some code, some opcodes to handle this. It will be a while, so let's not bother. Okay, now let's just commit this. Okay, now one more thing, let's add a new register. Division? Can I say division? I don't know. Yeah. Yes, I can. Cool. Introduce opcodes. Documentation. Let's just say docs. And now, what do we need to do now? Okay, let's just create a basic setup of the environment. So we have a CMake project repo. No, I don't want project repo. Okay, how will name the virtual machine? So English, it's like English speaking virtual machine ESVM. Yeah, cool. I'll take it. So the virtual machine is going to be called ESVM. And now I don't want to have source code here, so let's create a diagram. Yeah. So let's create a folder for actual virtual machine project, because it will be a sub project of this project. Now let's create utils cleared external, because in external I'm going to have the Google tests source code, because I often program outside of my house, so mostly without internet, so I'm just include the whole Google test source code here in my repo. But yeah, not now. So yeah, utils. In utils I'll have some utils, of course, and virtual machine. I think I will divide it into two. I mean, the whole engine of the virtual machine is going to be in separate library, and the virtual machine is going to be in a separate executable. So yeah. Okay, yeah, let's start from basics. So remove this, and now subdirectory external cool, add subdirectory, our virtual machine, and the utils as the last one. Okay. Now I won't bother with Google Test for now because there's no reason for that. Because I'm not going to write any tests on this stream because those are boring. I'll probably do it offline. Reload changes. Okay, okay. Let's move the main to virtual machine. Yep, and let's create a yes. Let's create an executable here. Project name and with files main cpp. Cool. That's simple. And let's create a dummy. Yeah, okay. Let's remove the external for now. So utils. In utils, yeah. Let's just remove it for now. So let's run cmake. Load. Utils, okay. Reload. Finish. Cool. Hello world, works. Produce basic, I don't know, build system. Okay, so the first thing about actual coding won't be the virtual machine because, to be honest, I don't have what to code there and how to test it because I don't have any program, any operating system for this. So the first thing that I will actually that I'm going to actually code is going to be new directory. What utils? I shouldn't have removed that, but yeah. Okay. I'm going to implement a very simple cross compiler from my assembly, of which opcodes I just wrote to the actual binary opcodes. So yeah, cross compiler project. Yeah, let's go like this. Subdirectory, no. Yep. Okay. Wow. Let's create a main here. Cool. Let's sources. Yeah, main cpp. Add executable. English speaking virtual machine. Cross compiler. Let's just fully name it. Okay, main. Do we have something? No, we don't have. Include IO stream. Int main, and let's just put something here. Yeah. How? No. No, I don't want these utils. Yep, reload. And add subdirectory. Utils. Yep, reload. Oh. Oh yeah, okay. Sources. Does it work? I need to reload that or not. Let's just set cache and okay. Yep, there's a target. Let's build it and run. Cool. Cool. Utils. Before committing, I will create a new directory for this. Cross compiler, let's say. Okay. Yeah, move that. And you just create a new CMake here, which is going to just add subdirectories. See? Yeah, preload, build, run, cool, works. So yeah. Introduced. Cross-compiled project. So now let's just create a class for cross-compiler that is going to accept I think the source and yeah. Yeah, let's see. Oh, now first things first, let's just create a Lexer. Of course, some namespace. English speaking virtual machine. And now, so the first thing I'm going to create is a Lexer that will translate the raw string of assembly source code into the tokens. Yep. So yeah, let's say we're going to return a vector of tokens. Tokens. Okay. String. Okay. Now I'm going to add explicit variable of make variable for C++ compiler. which is going to be clang plus 7. Okay, and now let's reset cache and rerun the CMake. Let's see whether we have string view. Yep, now we have string view header. Cool. Cool, very cool. So, Lexer is going to assume that. Okay, let's create another namespace. Let's use nested namespaces, which is going to be cc. Okay. Lexer is going to assume that the source code, the assembly source code, is going to live for the whole, let's say, program execution. So we can just return a vector. Yeah, we have vector of string views. Lex. Cool. Private. Private. So Lexer is going to accept reference, const reference to. I need a string here. A reference to a string with all source code. Let's just say source. Okay. Let's here just store that reference. Now let's store iterator. Const iterator. So yeah, let's just name it R. So we won't store reference to a whole std string. We will store iterator to the characters of the source code, and we are going to operate of the mchar instead of some other shit. I wrote a couple of Lexers in the past and it works like a charm, so yeah. Lex. Yeah, let's go to the no here and implement a couple of methods. Lexer, yeah, let's just have it all in one directory. Cool. Okay. And the Lex. Okay. Cool. I think I'll actually include the external Google test project because let's just go with the TDD or so. I'm not an expert, but yeah, let's try write some tests for Lexer and then implement the needed functionality. So Google tests, cool. Okay. Git clone. Okay, let's remove the Git repository. Okay. Now let's go up and create a CMake list in which we are going to add subdirectory Google test, and that's it. Let's go up. Create status. Okay, there's a lot of this. So let's add everything from external, and it's still a lot of this. But now let's okay. Let's add an external subdirectory here. External. And we are ready to go, I think. So let's commit imported Google test. Yeah, I spelled it correctly. Cool. So first, external Google test. Okay, we don't bother with this anymore. Now let's create a test directory here and create a main for tests, which is going to look okay. Let's create a CMake list for main. Test. Test. Project name, sources. Sources. Okay, main. Cool. No test name here. Okay. Nope. Cool. Tests. Okay, just name. Add sources and let's add target link libraries. So the project name and now let's see how Google Test is doing this. Where is the CMake? Okay. Okay, using CMake, my build. Existing CMake projects, no. No. Subdirectory, no. No. Okay, legacy, no. Sorry. Okay, let's just gtest main. It's a link to gtest main. Reload. worked. Make cool. Add executable, cool, but let's add subdirectory with tests actually. So let's rename it. Refactoring. I'll just quickly check on the phone whether my stream is online, because blah, blah, blah. Yeah, YouTube says that I'm offline. One two one two one. One two one two one. Okay, I'm online. That's good. Let's continue. So I added tests here, and it's not an existing directory. How? Reload. Okay, no. I renamed it. Refactor. Okay, whatever. Let's name it test. Now, okay, warning. Yeah, warning about this. Why not? And do we have tests? Cool. And there's nothing in main yet. Okay, it builds. Okay. Gmod H. Okay, let's link Gmod because we are going to need it anyway. Gmod main. I always wanted to implement my own virtual machine. So yeah, let's make it happen. Gmod H. Is it going to compile? Yep. Well, there's no main function yet, but int main and yeah, testing setup. Shit, I don't remember. Gtest main function primer. Where is main? Yep. Let's copy that. Cool. Run all tests. I hope there's going to be yep, 0 test. Cool. So let's see what we have here. Git add. Modified utils cc, yes. And all from tests. Introduce CC tests infrastructures. Infrastructure. Infra. I spelled it wrong. Infrastructure. Infrastructure. See. Info. Structure. Cool. Infrastructure. Introduce CC infrastructure. Cool. Let's add a new file for Lexer tests. Lexer test. Yep. Include gmok. Gmok. No actions. H. Namespace. English speaking virtual machine. Tests. So the first test is going to be, let's say, just one token. Lexer test, or yeah, empty source. Get empty tokens. Cool. So const auto source going to be empty. Now let's include our Lexer. No. Yeah. Let's do a dirty hack, but oh yeah. Yeah, fuck it. Let's do a dirty hack and add as no, let's do it in proper way. So let's create a library with all classes. Set. Okay, let's create another. Set. And let's have it here. Cool. Now let's add a library. And it is going to have such name, or even better, library. Now with sources, cc-lib sources. Cool. It's going to be a static library. And now after add executable, target link libraries and project name. And project name lib. Cool. It should work, but yeah. And now Lexer test is going to link to this library. Not project name, but Okay, let's remove this. Test. Test. And just project name lib. Let's move it to one line. There's no need to keep it in the another one. So target includes directories. And let's add, just current source directory. Yeah, sorry. Next to that, when we link in our tests to that library, I think we should also target. But yeah, public. I think we should also have this directory includes directory like derive the and include directories to here. So in the test should be able to just include the Elixir HPP. It does not work now, but yeah, it works. Cool. Git st. Yeah, let's just add CMake. Cool. Not Elixir but cclib. And linked that to the test exec. Executable. Yeah, should have not named that exec because that's not the only Windows thing, but yeah, whatever. So now let's write our first test source, empty source, and result tokens, and that is going to be Elixir source lex, and we now let's just add using equal expect empty. No, there's no that. Result tokens are empty. There should be something like empty. He's empty. Okay, he's empty. I'll take that. Cool. He's empty. Result tokens. Now we have undefined behavior because our lex method doesn't return anything, so let's return just empty vector. Yep, it works. Added Lexer class and the first test. Cool, now let's create another test. That is going to have a single token, let's say. Single token, get empty tokens, now get one token. So, yeah. Cool. Result tokens. And yeah, let's check its size. And assume it equal 1. Okay, so obviously the test now fails, but we are about to implement that functionality, actually lexing, the lexing functionality. So first off, lex. Oh, yeah, let's just comment here what tokens can we have. So we can have comma. We can have like dot in assembly or floating points, but I won't bother about floating points right now. So yeah, identifier. Identifier, open square bracket, close square bracket, new line of course, but let's not bother about new lines. Let's assume that you can write assembly code in just one line. Labels are going to have, so like shit, I forgot how how it's called in English. How it's called in Polski. Semicolon. Of course. Cool. Now let's create an enum with token types. It's going to be just a header file. Token type. Cool. Oh, I forgot that in the Lexer. Oh, no, yeah, no. Okay. Token type, and now identifier. So yeah, first one will be undef. We'll return that in case of any error. Undef identifier, comma, semicolon, open square, open close square, close square. Yeah, but let's just save that for now. Colon. Cool, Lexer. So yeah, we have comma, identifier, open square. Yeah, okay. Now let's just implement a switch let's say for now, switch. Now there will be a loop while is not an not at end. So let's just now implement that function, but to implement that function we need to actually store the end. So now end is going to be source cend actually. So yeah, that can be cbegin. I need to hire Clang format for this, but yeah, not now. And let's create a function is at end. Mcar is equal mend. While we are not at end, so let's create tokens here. Oh, yeah, let's create tokens here. Of string views, tokens, string, and let's just create return those tokens. So while we are not at end, let's create another function. Okay, so yeah, I'm wondering because we need to have token. Yeah. Let's now just not. Okay, I'm wondering about how can we represent tokens, because we can have tokens, like we have token type, but token type has one enumeration as identifier, and identifier can be, for example, we have a lot of registers, like we have 60 couple of registers, so I don't want to create 60 couple of token types for only registers, but I think that would be the best idea. So in fact we would not to return a vector of tokens would not just be a vector of shit. No. Yeah, so I was wondering whether we can just return a vector of token types of the enums, but we can't, because if the token is actually, for example, a number, we need to somehow pass that number to from the lexer, return that number from the lexer, so we actually need the string view to then just not format, convert that to an actual number from ASCII chars characters. But so yeah, let's first of all rename that to from token type to just token, and let's okay, I didn't want this to be renamed, but yeah, let's create a struct token which has token type and string view, which is the actual representation of this token. Cool. String view. Screen view, contents, let's say. No, just str. Okay, so from Lexer we are going to return vector of this, but now we need to include this token. Cool, and change it here and here. Cool. So now we can do anything we want. Okay. While we are not at the end, let's get next token. Okay. Okay, yeah, and let's implement that. So token get next token. Get next token const. And in get next token, let's have just switch off on the current character. Is CLion actually okay? Default state only. Let's not bother. So now let's just create cases. If current is comma, let's say get one har token, and it's going to be comma. Cool. The cool thing is about that is that we can just create one function, get one card token for a couple of one card tokens. So another one card tokens are open square and close square and semicolon. Now let's implement the get one card token. Okay, no. Let's switch on car and case. No. Okay, we do need that. So token type, let's create a lambda for that. It's yeah. So we're going to create a console type of the token, which is going to be returned from the lambda. And in lambda, let's have a simple switch on C, and in case of comma, let's return token type comma. In case of open bracket, close bracket, and semicolon. Same. Okay, return. Not comma, open square, close square, semicolon. Cool. Default, let's not bother about default, so we can have a type. Now let's create a function it that is going to increment the character iterator. So void it. It's not going to be const. Why are I'm making those are const? Okay, this can be const, but getting token won't be const because we are going to increment the mcar iterator. So yeah, it by it. Let's just increment the mcar. Okay, this is not const. This is not const too. Cool. So now let's create a string view. Of string view and from car to std next car. Oh, and now let's go to it. And instead of just incrementing, let's advance that by 1. Oh, okay. Yeah, whatever. So std string view, why you don't want this? Yeah, okay, so 1. There is no constructor of string view from the iterator. Constructors, so okay. Okay, I don't want to check that here. So strings library, basic string. Cool. Const iterator. Const pointer. To character pointer. Shit, of course I can dereference that and just take a pointer to this. Obviously. So now let's get a pointer to the referenced character. Cool. Let's just see what's going here. The reference character is yep, it's going to work. So we have string view for this, and now let's just return the token with type and string. Get one card token, so yeah, return that. In any other case, we can have a number or identifier or yeah, let's just now eat. I didn't eat anything. Eat. So let's go to the token type because but identifier we can have, like I said, number. We need to handle that too. Yeah. But for now, let's just commit. Let's see what we have here. Token, yeah. Get one card token. Let's write test for this. Okay, it's kind of late. So yeah, let's write tests and finish for now. So it would be good to implement parameterized tests. So yeah, let's do that. One card token. What do I need now is test state. Or no, yeah, I don't remember this that much. So let's finish for now, and let's go back to this. I think I will write that tests in a spare time. So that's kind of boring, of course. I mean, tests are helpful, but this one, those tests that I'm about to write are quite boring. So yeah, I will. Like I said, I'm going to write them in my spare time. And for today, let's just drop it and finish, because I've been talking for like hour and a half. So yeah, let's leave it. Okay, thanks. Okay. I'm just going to push I'm going to push the code to the repository on GitHub. So yeah, see you there. Bye.